Hey, Swedish Terapeut there. Hey. Um, it is Thursday, July 15th. It's 2021. And this is the day after um, France had their national holiday. So I don't know French, but I looked it up in Féte Nationale. So I said happy birthday, post happy birthday to the United States. So I might as well say post happy birthday to France because at one time, France and the United States were really good friends. Benjamin Franklin used to go over to France all the time because it was the hot spot of fun and entertainment and thinkers. So maybe it still is. I just haven't been there much. So we had been discussing the Vätska, and we had this book. So you saw all the liquid that was around the embryo and before it was being made. So we had pictures. But now we need to finish section 2, episode 2 of the Vätska, the in between. So follow me. Let's go. It has been pared down so much. So we're going to share the screen. And we pared it down so that you weren't incredibly bored. And we pared it down so that it was understandable. Oof. So here we have information from the beginning of the Vätska. So we had episode Vätska 1, and that was talking about electrolytes, and that was talking about pH, which is pH, and ions, and all sorts of things. Gases as well. Lots about gases. Then we did an in between. And on this last episode, before we did everything about the book, we talked about Dr. Sally, and it was her birthday on July 6th. So I guess I'm going to back up a little bit. And I said, happy birthday to France. Oh, and then there's this billionaire named Jeff Bezos. Maybe you've heard of him, but he retired. And July 20th, so very soon, in 5 days, he'll be flying up to space. And apparently, competition is good because there's another rich guy, Branson, who just came back from space. Yay for them! Glad they have the money for that. So the last time on episode, the in between with Dr. Sally, it was appropriate because of her story. So we've been talking about stories, and Yuri Hassan talked to us on the TED stage about what is physical entrainment so that he could actually explain neural entrainment. And neural entrainment is wonderful with storytelling because storytelling, the listener gets engaged and their listening skills sync up and couple with the storyteller, and we have learning. So physical entrainment is very much similar because physically things start to sync. So if a metronome is out of sync, as in physical entrainment, then the metronomes start to sync and get into a rhythm and they oscillate together. They sync. So we went on to tell stories. And the story of Dr. Sally is very appropriate because it is discussing her lifelong work, her practice, how she was a doctor, how she also used food as medicine, and she was an excellent cook. That woman could she could whip up anything. You give her cardboard and she would make it edible. So all of these life experiences formed her and they shaped who she was. And as I say here, her metronomes coupled together and she learned. So I'm just saying these things as a story because had Dr. Sally not had scarlet fever, had Dr. Sally's own doctor not climbed up the second story window of the family house in order to treat her when she had scarlet fever, had she not had those experiences, and also the experiences of her grandparents living off the land, and her grandfather coming home, and everyone in the family contributing to putting food on the table. Had she not had those experiences, I don't know who she would have been. Most likely, she wouldn't have been the woman I got to know. And I'm grateful for that. So, Dr. Sally was full of integral grit. Yes. Her integrity remained lifelong, as long as I knew her, and she's still alive as of today. Um, but what I don't get is, how did she adapt through the circumstances of life? Life was not an easy situation, and life usually isn't easy. Her story is a snapshot of life in general. How is it that she maintained her integrity, her integral grit, and yet my mom, being a strong, smart woman as well, lost it? So, dear young people and common folk, this is part 2 of episode V, the Vätska. Vätska is the wet stuff. It's the in-between. And Vätska is a Swedish word. I made up the meaning because I have to come up with ways to remember the Swedish language. It is so new for me. I'm 5 years into living here, and there have been challenges. So, Vätska, the wet stuff. So, Swedish Terapeut would like you to know, in the in-between, the Vätska, there's substances. And like a river carries substances to the ocean, substances live within our compartments. Our compartments being, let's just say, 3 easy things: a solid, a Vätska, and a gas. And they flow, they blend. And when they flow, there's a rhythm, and they synchronize, and they couple. And you think about how the heart is, and there's a certain beat. And when your heartbeat is out of rhythm, there's something going on. Humoral factor substances, humoral factors. This is the British spelling, and it includes the U. So I divided it up. Instead of saying humoral, without the U, which is almost like something being funny, then I put a U in there as the British spelling. So we discussed electrolytes and ions and pH in the Vätska number 1 episode. We also saw in picture format Lennart Nilsson's book, Life. There we saw how substances blend. And when substances blend, the whole is life. And life has parts: life, growth, death, and decay. That's just part of life. Substances blur, and when that happens, the whole loses integrity. And the whole is compromised. And that's where my mom is. So let's talk about humoral factors. They're substances. It's a long, complicated list of substances. I read some open access research papers every now and then. And some of the names they have for these things are crazy. But it's a long, complicated list of scrambled, non-alphabetical letters involving human physiology and psychology. And if you remember from episodes past, we talked about physiology, and physiology being something that is involuntary. You can't think your way out of a situation. You can't think your way out of the heart going 1,000 times a minute because somebody has yelled fire, 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 fire. Physiological responses, they just happen, which is cool. We learn to adapt. So our psychology and our physiology are very much intertwined. And Swedish Terapeut has not found an organization or group which categorizes humoral factors most likely because it's a throwback from the Greek days of the four humors. So if you want to know more about the four humors, we talked about that in episode Vätska 1, V1. So science does a really good job making things difficult, complicated. Now, there's a difference between complex and complicated. Complex is life, it's Mother Nature. And complicated seems to be man-made. So science has fancy words, and they say admixture. And admixture is mapping, and it relies on the quirks of human genetics. So here's an article from recently from the Conversation, Mixed Ancestry Genetic Research. And I put that on there so you can see the authors. And it was done July 14th, which was yesterday. So admixture. Admixture mapping is a blend, but not a smooth blend. So what I want to say about blending is that all of our ancestors before us make us who we are. Traits and perhaps behavior are deeply etched into our DNA. But then there's epigenetics. Epi is a Greek word meaning above, on top of. It can mean near. And we'll just stop with those meanings in the Greek, epi. So epigenetics. So using the awkward thinking and thinking in a different direction, in a sense, epigenetics is free will, because our genetics are one factor, but our epigenetics is our behavior. So our free will is the ability to determine our own future through behavior. And we have conscious behavior, very different than physiology, which is involuntary. So my mom no longer has an ability to have free will. It's crazy. Her body works, parts of it, but her mind and her psychology is abnormal. It's just not there. So my question, dear young people and common folk, how do we maintain free will for as long as possible? If you have it, hold on to it dearly, because once it's gone, it's very hard to get back. Humoral factors are substances involved in human physiology and psychology. So I have to, yes, I do. Swedish Therapist wants to introduce you to an incredible man, Wallace Carrothers. And Wallace Carrothers is one of the men in the team at DuPont in the 1930s that made the first synthetic fiber. And this has changed your whole life. And it's changed my whole life too. And the coolest, cool little fact I found when I was researching this is in the 1930s, DuPont had a place in Wilmington, Delaware, and it was the same area that the Swedes, a bunch of Swedes came over and colonized and called it New Sweden. So the New Sweden of the Americas was on the Delaware River in what's now Delaware, New Jersey, Pennsylvania, Maryland. So everything changes. It's an interesting flow. So Wallace Carrothers was an intelligent chemist, a complex man, and a person with an intriguing brain. He went to public school in Des Moines, Iowa, where I lived for a long time before Sweden. Wallace Carrothers had depression, though, so his psychology was challenged. But despite success, despite a passion for organic chemistry, despite being a university professor and despite being a group leader for a cutting edge team and the newest technology possible in the 1930s, and despite a curious mind and curiosity, somehow he couldn't hold on to that. And unfortunately, 7 months before his baby daughter was born, he left this world on his own terms. And I always, it saddens me tremendously because having depression is not a fun thing. I don't wish it on anyone. And if you're in that situation, make sure you call somebody. What I'm trying to say is, how could our world have been different had he lived? And our world could have been very different. How does somebody lose their psychological integrity? Dear young people and common folk, this video is for you. I don't know the answers. I just want some help figuring it out so you don't have the experiences that I've had regarding my mom, and you maintain your own integrity. I think I went too far. No. Oh, yeah. So we talked about, okay. Technical difficulties. There we go. So physiologically and psychologically, humoral factors blend, and they're involved in both processes, and they blend to make things, and they blend to make us. So a polymer, poly is Greek for many, and the mer is must be Greek for part. So polymer is many parts. So many parts in this term is a material or substance consisting of very large molecules or macromolecules composed of repeating subunits. Due to their broad spectrum of properties, both synthetic and natural polymers play essential and ubiquitous roles in everyday life. And unfortunately, this one didn't come in. It's Wikipedia polymer, if you want to look it up. This is the book right here that we talked about, Life. And this is the YouTube link for when we did that. That was July 12th. But let's go back to the episode on Netflix, Everyday Miracles. In 2014, it was released. It's season number 1, episode 1, called Home. And at 50 minutes, we have the host talking about a polymer of plastic fiber. It was made with 2 chemicals. One was an oily-based waxy solution, and the other one was a water-based solution. So 2 liquids combined to make a polymer, and it happened to be Wallace Carrothers and team. So the small molecules of each liquid, they're capable of bonding together with the molecules of the other, and they form larger molecules, long chains called polymers. This is the most interesting to me. This is what the host said. Where they meet is where the polymer forms. It's a meeting ground. So like plate tectonics, you have two parts of plate tectonics, and where they meet and they kind of shear on each other, that's where the next layer is formed, that shearing effect when they're moving across each other. It's like the extra little debris. Now, I'm not a scientist, geologist. Forgive me, Rosemary, the rock doctor. But I think that's a very good visual. So where the 2 water solutions, liquids, meet, a chemical reaction takes place and it makes a delicate little film. And the polymer is created between the 2 liquids. So removing the film delicately with tweezers is what the host did. And then a fresh boundary is created, and the reaction continues and continues and continues. And what the host did is he put it on a rotating spit, and that thread, he just cranked it. And because there was liquid left over, there was always a thread. So he got a huge long chain of plastic as long as he kept pulling, and it continued to have liquid. So it was the coolest thing. And that was called nylon. And that's what Wallace Carrothers and team made. And I still don't know how somebody with such a curious mind and such an intelligent intellect can lose their psychological integrity. So the modern word that we use is tissue, and it comes from the French. Happy birthday, all French people. So I don't know French, but tisser, French verb meaning to weave, and it comes from the Latin textere. So when things are woven, and you can kind of see how those two layers of liquids sit on top of each other, the watery layer and then the oily layer, and when they meet, they create a little film. And if that film is pulled, then we get a thread. And you keep on making thread, and then you can weave a tissue. So tissues are blends of all three compartments, solid, Vätska, and gas. And a polymer is the result, and it's a solid made from the two liquids. And if we pull on it, then we get a thread or a fiber. And here we can see that I did American English and then British English. And Julian Baker would be very happy that I included the correct spelling right here, fiber, R-E. So Dr. Antonio Stecco from Italy, who's working in New York, talks about the skins, our first skin, our second skin, and our third skin. I had to go get this. This is wood. My husband doesn't know why I carry these things around, but it's in our house, and we have one out on the porch. But here's the bark, and so that would be like a first skin, and then maybe a second skin, and then there's even more skins and third skin, because this was a huge tree, nice and round. So let's go back to the recording or the presentation so you can see that again. I know. You are on a rice cooker. That's why there's so much movement when I go click, 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 click. Well, I guess you're not on the rice cooker. It's the computer. So here we have a nice picture of a cut tree, and you can see there are little fibers, but the thing is that was a hole right there. So it has deep skin that started in the middle, and then it keeps growing out and out and out and out and out and deposited. So then we have an egg, and we have a nice tough skin here, thread, polymer, and then we have an onion. And every time that we have an onion and we peel another layer, there's that thin, delicate piece of tissue, or I guess in this sense, we'll call it a thread, or we can call it a tissue. Up to you. But they're tough. For being as thin as they are, they're tough. So I had a question. Mitochondrial DNA is a substance that comes from the human egg. And here is a mitochondria in cartoon form, because none of us are really seeing a mitochondria unless you're a scientist. So there's a cool video, Inner Life of a Cell, a full version that you can go on to YouTube and look at. And there's cool little mitochondria going along on his thin fibers, trying to find his way. Trying to find her way, I should say, because she comes from the egg. So it's a her. So that's her. That's mitochondrial DNA is bacterial. So in order, her DNA is bacterial or microbial. It must be depending on the DNA. And she is in every cell of our body, and she helps drive the cells. DNA is a chemical part of our humoral substance factors. It's the soup of life. And do they blend or do they blur? And if mitochondria in every cell is bacterial, then I had to ask, well, what's a fibroblast? Is that human or is that bacterial? So humoral substances are factors. Yeah. Humoral substances are factors that are involved in human physiology and psychology, but what about the plant kingdom? So we've seen the egg and we've seen the onion and we've seen the wood, but what kind of fibers and polymers, biofilms are produced or secreted or formed or made by their Vätska, their liquids? What combines? So in the plant kingdom, cells produce cellulose. So we have cotton and bamboo, and I'm sure there's more. And trees, they all have cellulose and they're made by the plant. Cellulose is a solid, which is insoluble fiber. Insoluble means it does not dissolve in liquid. These fiber proteins make cotton shirts, it makes all of our paper money. In trees, the inner bark or flume is a tissue, a conduit, a pipeline, a tunnel through which food is passed to the rest of the tree. So flume lives to carry sap. Then it stiffens to become part of the protective bark. Yeah. And you can think of cork. Cork is part of the tree and it protects the tree. So flume has cells and ground tissue. Ground tissue. Cells and ground tissue. You feel it's not ground as in earth. It's ground as in the basic, the foundational, the functional tissue. And it's traveling in, on, through the tree from the roots in the ground all the way to the shoots. So from roots to shoots. That's the cellulose of a tree and plants. Now, we've talked about polymers, but what about in something more mammalian? We've talked about fibers, and a fibroblast in a human makes fibers. Fibroblast, I don't know if it's bacterial or human. But I can tell you that a fibrocyte is a fibroblast. And when a fibrocyte is making something, it's called a blast because the Latin terms for site is cell, and the B means building, and the C, if you see fibroclast, it means cleaning or collapsing. So we also have osteocytes, bone, osteoblasts, bone building, osteoclasts, bone cleaning or collapsing. If the fiber from an insect like a silkworm or a spider, so I guess that's not mammalian, but if those fibers, if when they make something, they make a thread or silk or a fiber, a polymer, a biofilm, so we call it a thread of silk. And if you've ever felt silk and it's all stitched together in a tissue for a shirt, beautiful. Fibroblasts produce, secrete, and make a solid, a thread, a biofilm in science speak. The fibroblast is a cell floating around in the Vätska, doesn't dissolve, it's insoluble. The behavior of a fibroblast is to make fiber, a thread, a biofilm, a solid. Solid is one of the three compartments that we've been talking about. Connective tissue of various fibers are blends, and various blends make us. And various blends make a plant. Yep, for some reason I'm having troubles with my up and down keys. Apologize for that. So substances within the compartment of Vätska, because we're talking about Vätska, which is in between a solid and a gas. When they combine, we get our own things formed, our skin. And not only our skin, but different parts of skin, which is collagen. So like a river carries substances to the ocean, Vätska carries humoral factors. Fibroblasts secrete a protein, a solid, a fiber. It's a thread, or AKA a biofilm. In the animal kingdom, the most plentiful is an insoluble fiber that doesn't dissolve in Vätska, but in the human body, us, there are many proteins made from amino acids. Proteins blend to form collagen. And there's collagen type 1, type 2, type 3. And I think at this point, they have over 32 types of collagen, and they're finding more. And I can't tell you how many proteins we have in the body because it's a huge long list. But so for simplicity, we will say collagen is a solid, a fiber. In the British, here you go, Julian Baker, Fibre, R-E, British. Call it, you spell it whatever way you want. A thread, a polymer. Just know it's a biofilm. And it's a solid, Vätska, and gas. So the wet stuff compartment is collaborating, and it's collaborating and it blends. And if you go to Google and you search humoral factors, probably without the U, gosh, you're gonna get so many different things. There's enzymes, and there's vitamins and hormones and steroid hormones and neurotransmitters and lipids like fatty acids and various other neurochemicals. And I can't do any of them justice with this one talk. But an enzyme, according to Medical Biochemistry book in 2017 by authors Antonio Blanco and Gustavo Blanco, is that enzymes are catalysts. And within log ohm conditions, and here's our balance, within log ohm, when everything is a moderate amount, moderate conditions of temperature, moderate conditions of pH, power of hydrogen, moderate conditions of the pressure of cells. And we've long time ago, we talked about tensegrity, and we talked about push and pull. It's a compression and a tension all at once. It's mechanical. Truc. Pressure of the cell. All of those conditions, if they're log ohm, enzymes are working well. And they carry out chemical reactions at amazingly high speeds. Chemical reactions that are characteristically, it's with efficiency when enzymes are present. And the substrates, substrates are the substances on which enzymes act. Substrate. So I just have to say, a lot of coenzymes, this came from the book, are associated with vitamins or come from vitamins. And there's many diseases out there, from Lyme's disease that the sailors got because they didn't have citrus fruit, to all sorts of things. They come from O-log-ohm, which is O-synced, out of rhythm, out of balance, deficient, brist, which is Swedish, lack of. Oh, And then you have this beautiful, gorgeous little mushroom all by his lonesome in nature. I just thought it was beautiful. So I put it in there. You can read more about it, but myocycle.com. Pretty cool website, by the way. So the wet stuff. There's more because we talked about before electrolytes and pH and ions. And so here's hormones. And I can't do it justice because there's too many hormones to talk about. But there's a hormone called osteocalcitin. And I say it's a humoral factor. I think it was 1995 that they found it. I mean, it was there before, but science actually found it. And science finds things all the time because technology changes and it becomes like, oh, we didn't know that was there. At one time, we didn't know how this was formed with the egg and with sperm, but now we do. Very cool. But there's more to learn. So keep coming. Keep going. Osteocalcitin is a protein. It's made by our bones. So our bones are actually endocrine organs because our bones produce our blood, but also they produce osteocalcitin. So it affects male testes, the brain, the heart, the liver, and the pancreas. So that hormone affects many different organs. Osteocalcitin has a relationship with insulin. It's a regulator of glucose metabolism. And they get that because they've observed mice. So when a mice is deficient in osteocalcitin, it can be hyperglycemic, meaning too much glycemic index, too much glucose, and having a hard time regulating it, and hypoinsulinemic, which is too low in insulin. So it's the scale and it's out of balance. So olago. So studies suggest a broader role for osteocalcitin that extends to the regulation of whole body metabolism, reproduction, and cognition. Super cool. So when I learned that, and I was teaching at a folkhögskola here in Sweden, and I learned that, I thought, I'm going to start eating more yogurt because I need vitamin K2. So my ability to cope with stress, and I know everybody has stress. How can we not? This is just daily living. But in order for me to cope with stress better, I eat yogurt. Vitamin K2 influences osteocalcitin in our body. I can't drink milk. From an early age, my body was lactose intolerant. And I never developed a taste for milk products because of that fact. Even lactose-free versions, I just don't like it. But fermented milk products, I discovered here in Sweden, they don't have extra sugar put in them. They're really tasty and they're a little bit acidic. So my family appreciates it when I have it in small amounts because I don't have farty pants. And I like it because I'm not bloated if I have it in small amounts. And yogurt, this yogurt right here, that's my Russian yogurt. Yeah. It's my Russian yogurt and it's liquid. So I just ate it this morning on some blueberries. And I don't know if you can see that, but I didn't have any liquid in there at all this morning. And now there's liquid. So where does the liquid come from? It must be alive, right? Huh? So I looked it up. Gut bugs love K2. And in small quantities of organ meats, which the United States hardly eats any organ meats anymore. My mom used to love chicken gizzards, chicken liver and chicken gizzards. And tell me the last time you've had a chicken liver or chicken gizzards. She used to eat it all the time. So I eat fermented foods like this because my gut bacteria also produces vitamin K2, and they love osteocalcitin, and they love K2. And this is where I'm getting it in my Russian yogurt. My gut bugs love it. Oh, and why? Friendly bacteria make fatty acids and other nutrients, and that gets blended into our Vätska. Fatty acids are made to add integrity to cell membranes. They are oils and fats and cholesterols and steroids. And if you want to know what I mean by an oil, sebum. It's mammals have sebum. The wax that you get in your ears that helps keep insects away because insects don't like the smell of wax. That's a waxy, oily substance, and our bodies produce that all the time. So friendly bacteria, when we have enough friendly bacteria, they keep the harmful bacteria within check. So the harmful bacteria don't start to blur our boundaries. And when microbes are logo, everything blends. But when microbes are O-logo, boundaries get blurred and they compromise. So here's two papers, really fairly easy reading. A paper in Bone in 2016 about osteocalcitin. And then here is Journal of Bone. I don't know what minor res is. Anyway, that's from Tokyo, Japan. So feel free to read that. It's next, osteocalcitin accumulation in the extracellular matrix of human osteoblasts. Oh, we've talked about osteoblasts, sort of. We talked about a fibroblast, blast being building. So osteoblast, bone building. So osteoblasts, blasts are specialized chemicals, and that, yeah, you can look that up. You can look that up. Osteoblasts are specialized cells that are primarily responsible for synthesis and deposition of mineralized collagen-rich matrix that composes bone tissue. Mineralized. And that was electrolytes. Minerals in a solution are electrolytes. Remember that from the last time we met? So the wet stuff. Hormones and other humoral factors affect our psychology and our physiology in an involuntary manner, and they affect our psychology or affect our mood, our attitude, and thus our behavior changes. So if you're in a room full of people and somebody has yelled fire, you're having a hormone like adrenaline go through your system, and you can outrun just about everybody in the room because that adrenaline is not a voluntary released substance in your body. That adrenaline gets you moving so you can thrive and survive. Cortisol is a steroid hormone, and we've heard about that when we talk about the stress response. And it affects blood sugar levels in the body. Cortisol is released from the adrenal glands, which sits like a hat on top of both of our kidneys. So if you have a kidney and you have a tiny little hat on top of it, that would be the adrenal gland. And in my massage therapy school in 2021, there was a woman there with 4 kidneys, and most likely each of them with our own little hat. So that was probably a lot of adrenaline when adrenaline was released. Fermented dairy provides K2. We talked about that. Microbes in the gut love K2 as a source of nourishment. And when a human eats vitamin K2, there's a boost of osteocalcitin production affecting bone health, muscle health, and brain health. My brain needs it. It's all related to the whole. That's why I feel better when I have my bowl of Russian yogurt on my blueberries. And everything blends to make me a better mom, a better person, a better wife, a better massage therapist, and happier with myself. Oh, but there's more. We have another humoral factor. We've heard all about cytokine storms. That's we've heard that in the news 2020. Ugh. Cytokine storm. A cytokine is a substance which modulates the balance between humoral and cell-based immune responses. Go to Wikipedia to look up cytokine, that tells you more. But look, the balance between humoral, liquids stuff, Vätska things, and cell-based immune responses. And there's different types of cytokines. And I went to school for massage therapy in 2001, and I started my practice in 2002. And I don't remember anything about something called a myokine. And a myokine is a type of cytokine, and it comes from muscles. So as of 2003, these were newly discovered, but they're not new. They've always been in the body. It's part of our physiology. We just found it and put a name on it. So they're endocrine and paraendocrine hormones, and there's a list of names: IL-6, interleukin-7, brain-derived neurotrophic factor, and oh, look, interleukin-6. I put that twice. Other myokines include osteogenetic factors. Yes, look at all those names. And they improve endothelial function of the vascular system. Vascular meaning blood circulation. And this particular one is dependent on myokine irisin, which drives brown fat-like development. And a baby can keep itself warm because it has a lot of adipose tissue that is brown fat. It's an insulator and like a conductor. It generates heat. Fantastic. Myokines. The first one was identified in 2008, being myostatin. Skeletal muscles, when we do something to stimulate skeletal muscles. When we walk, when we run, when we dance, when we play soccer or football or football or football. We play at a park, we fly a kite, we garden, we clean the house, we fetch water, we swim. All of it is exercise. All of it is using our skeletal muscles. So myokines have been found to positively influence our mood, our cognitive abilities, and notably exercise, and it somewhat helps with sleep. So if you're sitting around, start moving, because fluid needs to flow. And as I Google searched humoral factors, and there's all sorts of them, microbes in our gut secrete, make, produce vitamins, fatty acids, neurotransmitters, and more. These are essentials for life. Microbes must have enzymes to do their thing, and remember from before, many coenzymes come from vitamins. And here's two incredible people we've talked about. Well, we haven't talked about it. I'm not a chemist. I'm not a physicist. I'm not a psychologist. I'm not a biologist. I'm not a physiotherapist. But I'm a massage therapist and Terapeut på svenska, because I like the way Terapeut is spelled. But let's meet a biologist with her ending of IST, makes her a person study of biology, and a physicist, study of physics, Knut. So Bonnie has a talk at Augsburg University, manipulating quorum sensing. In about 27 minutes, she introduces the group to fluid flow from physicist Knut. And he says, the world works under pressure-driven flow. It is more about curves than flat surfaces. Everything has curves. Only in a lab are samples grown on flat substrates. That might not mean anything to you, but take a minute or two, go to YouTube, and hear from Knut Drescher himself. Science in action. How is bacterial quorum sensing influenced by microfluidics? Here's our last one. You deserve to know. Vätska, the wet stuff, the in-between. Fluid flow. Fluid flow. Humoral factors, substances within the Vätska, the wet stuff. Humoral factors, substances are within the Vätska. Lagom amounts versus olagom amounts. So lagom, olagom. That's dry. That's wet. Here is a land bridge built by a beaver. And we've talked about the in-between, the Vätska. Substances live within a compartment, a solid, a Vätska, a gas. Flow is a rhythm. Think of the heart. Humoral factors are substances like we discussed in episode V1, electrolytes, ions, and pH, and we discussed hormones here, and we discussed all sorts of things. Fibers. We saw pictures in Leonard Nilsson's Book of Life. Substances blend, and when substances blend, the whole has life. And when substances blur, the whole loses its integrity, and the whole is compromised. And what I was thinking is, have you ever seen a hormone? And you probably haven't. So let me just take you on a really cool tour. Oh, sorry, that screen is shifting and moving. A really cool tour. All right, let's see. Yeah, so why not look at some really cool pictures of hormones? I know I should have done this before. Now, I'm going to show it to you, and then I'll tell you what it is. I'll try to get rid of the glare. Yeah. So if anybody is looking at this, I hope somebody's looking at it. It looks like a landscape. Isn't that the coolest thing? In the middle with mountains and ice and snow on the mountains, going down into an orange valley with some trees. Just beautiful. But it is a precipitate of testosterone. Pretty cool, huh? All right. So here is crystallized testosterone. It's too much glare. So that's a hormone. That's a male hormone, but females have that too. And let's look at this one. Here is the female hormone estrogen. Kind of looks like a butterfly. And that's the female hormone estrogen. And here's the female hormone progesterone, 29 and 30. And this is progesterone. So now you guys have seen hormones. And for anybody that is male or female, or anybody with an X or XY, and Swedish Terapeut has awkward thinking. I know I've talked about how science says only one sperm can go into the egg, and that one's carrying either an X or a Y chromosome. What happens if more than one sperm gets in? So my niece was born a niece, and he's 14, and he's now not my niece. He's my nephew. So was he really XX or was he XXY? So things to think about. Things to make you go, All right, I'm done for today. That was a very short version of a super, super, super long episode. Have a wonderful day. Tack så hemskt mycket för att kom hit. Hej då.